Hey, welcome back. We're here for question number 2. Now, one of the things you're going to notice in this problem is that there's only one place where we see x, and that's this guy right here. And that's kind of a good thing for us because when you see x in only one spot, that's usually one of those peel away the layer problems where you start with the stuff that's on the outermost part of the problem and peel it away. So here's x stuck right here in the center with 9. And he's got a square and a 5. This minus 1 is the guy that is least connected to that. So we'll get to that guy here in just a moment, but what we need to understand is that you basically have something that's x squared. It doesn't say x squared, but you've got the x contained in the square, and so this is something that's going to be quadratic. And one of the first things we try to do when it's a quadratic equation is to see if I can use the square root property. The square root property is only going to be useful if you only have one instance of x, like we do here. So let's peel away the layers until only the square remains, and then I can use the square root property. So first, let's get rid of the 1 because he has no real connections or ties to the square. So now we've got 5 times the quantity x plus 9 squared equals 30. Many times when I was going through my students' work, they were either squaring x and squaring 9, which just makes things worse, and it's also wrong because they're forgetting the middle term. Or a lot of times there's this, I don't know what it is, like an instinct to try to distribute the 5 inside here, but you can't do that. The power would take precedence over this multiplication times 5. So he can't sneak inside. Again, we're trying to get the square by itself, so let's get rid of the 5 that's connected through multiplication by doing the inverse operation, which is division. So we divide both sides by 5. That gives me x plus 9 quantity squared is equal to 6. And it's at this point that I can use the square root property, because that's how I get rid of the square. We take the square root of both sides, and when we do this, we have to remember plus or minus. The plus or minus does not come in at the end. The plus or minus comes in immediately when you use the square root property. So the square root of the square gives us x plus 9. And over here at the square root of 6, you want to try to factor this guy to see if there's a factor that's a perfect square, but there's not. 6 only breaks down as 2 times 3. Both of those guys are prime, and so there's nothing you can do except to write plus or minus the square root of 6. To finish getting x by itself, we subtract 9 on both sides. Whenever there is a plus or minus already in play in your problem, and you've got to move something over to that side, you need to make sure that you write that in front of the plus or minus. So this is negative 9 plus or minus the square root of 6. You could rewrite this one with the plus and one with the minus, but there's no point in that. Because if you look at this right here, negative 9 plus the square root of 6 cannot combine, at least not through addition. So we know here that we are done, and there's nothing else to do to simplify. Stick around for question number 3.